Alright, so next we have chapter 3, section 6. We're going to be graphing inequalities. So a quadratic inequality in two variables can be written in one of the following forms, where a, b, and c are real numbers and a is not 0. So we are still dealing with quadratics, which, if you remember, is a parabola-shaped graph. In the past, we graphed regular parabolas, which we're going to use the same strategies to graph our parabola inequalities, but we're just going to have an extra step added in at the end. So we have 3 steps to graph our quadratic inequalities. We want to graph the parabola in standard form, so this is our standard form, just as if it was like an equal to sign. We make the parabola either dashed if the inequality is just less than or just greater than, so this gets a dashed line like this. If we have an equal to, it has a solid line, so if that is greater than or equal to or less than or equal to, it would be a regular parabola with a solid line. Step 2 is we test a point inside the parabola to determine whether the point is a solution of the inequality or not. If it is, we shade the inside of the parabola. If it's not a solution, then we shade the outside. So we're either going to shade inside or outside. Either way. So it just depends if it works or not. So we're going to do some examples and put all these steps together. So in example 1, we have to graph our quadratic inequality. It's already graphed for us, which we'll practice graphing in a couple other examples. But we're going to practice shading here. So it's a dotted line because it's just a less than sign. So that's why it's a dotted parabola. But now to test a point, we can plug in any point inside of this U-shaped graph. So I'm going to pick a point just above the, well, I guess below the vertex. So here. So this would be -1, comma -2. Where -1 is the x and -2 is the y. So I'm going to plug in -1 into all of my x's and plug in -2 into my y. So I have -2 is less than -1 squared minus 2 times -1 minus 1. So I'm going to work out the right side of the equation and see if my inequality makes sense or not. So first I have to follow my order of operations, PEMDAS. So I have to do the exponent first. -1 squared would be +1, but I still have that negative on the outside, so it's actually -1. -2 times -1 would be +2 minus 1. So -1 plus 2 minus 1 would be 0. Yep. So I still keep that same sign that I have there, that less than sign. So we want to see, is -2 less than 0? -2 is less than 0. This is true. So if it's true, we shade wherever that point that we picked is. So I would shade inside my parabola. So my parabola is not only a dotted line because it was just a less than sign, but I also need the shading to be part of my answer. You have to graph the parabola, make it either a solid or dotted line depending on your inequality, and then shade. So there's a couple different steps than just regularly graphing. Can't forget shading. All right, we're going to do the same thing for the next example. Again, it's already graphed for us. I'm just going to pick a point inside my parabola. So it can be any point inside this U shape in here, any point. So I'm going to pick 0, 0, because that's inside. And 0 is going to be the easiest number to do math with. So the point I pick is 0, 0. So I'm going to plug in 0 for x and 0 for y. So we plug everything in. So I have 0, because 0 is y, is greater than 0 squared plus 2 times 0 plus 4. Well, negative 0 squared is just 0, and 2 times 0 is just 0, so these cancel. And I'm just left with 4. So 0 is greater than 4. We always need to ask ourselves, is this true? Is 0 greater than 4? It is not true. So that means we shade outside. So I have to shade everything outside of my parabola here. So because that point was inside that we picked, and it's not true, I can't shade where that point is, I have to shade outside. For the next two examples, we're actually going to have to graph, so we need to kind of remind ourselves, how did we graph parabolas? Well, these are in standard form, so I use my negative b over 2a formula, where this is a, b, and c. So I have negative 2 over 2 times my a would be 1, because there's no number in front of the x squared, so it's implied that it's a 1. So negative 2 over 2, which simplifies to negative 1. So this is my x. I have to plug it into the x's to find y's to get me my point for my vertex. So we plug it into all of the x's. So we are first just pretending that it's y equals. We're not solving the inequality, we're just graphing this first. So y equals negative 1 squared plus 2 times negative 1 minus 8. So y is equal to negative 1 squared would just be 1 minus 2 minus 8. So y is equal to negative 9. So my vertex is going to be negative 1 comma negative 9. This is the vertex of the graph. So I'm going to draw my graph over here on the side. I have to go to the left to negative 1 and down to negative 9. Put a point there. That is my vertex. Now I know because a is positive, my graph is going to open up. But I need another point on my graph. So since it's in standard form, I can use the c, because this is the y-intercept. This is where I cross the y-axis. So I'm going to cross at negative 8. So it's right there. So since I'm one space away from my vertex on the right side, I need that same point one space away on the left side too. So that would be my graph. Well, not yet. We still need to figure out if it's a dotted line or a solid line. So because it's greater than or equal to, that equal to makes it a solid line. A solid parabola. So if it was just greater than or just less than, it would be a dotted line parabola, a dashed line. But because it has that equal to, it's a solid line. All right, last thing we need to do is figure out how we're going to shade. We are either going to be shading inside or outside. So to shade, we have to pick a point inside to plug in. So I always like to pick 0, 0 if it's inside, because it's just going to be the easiest numbers to plug in. So I'm plugging in 0, 0. So 0 is going to go in for the x and for the y. So plug it into my x's and y's here. So just one y. We plug it in. So 0 is greater than or equal to 0 squared plus 2 is times 0 minus 8. So 0 is greater than or equal to negative 8. This is true. So if it's true, that means we are shading inside. We shade where this point is. So because it's true, we got to shade where that point is. It's either going to be inside or outside. You will never shade both the inside and outside. It's going to be one or the other. So that would be our graph. You not only need the parabola, but you also have to shade. All right, let's take a look at number 2. So the first thing I need to find is my vertex because I'm going to have to graph it. So to find my vertex, I use negative b over 2a, where this is a, b, and c. So this would be negative 1 over 2 times 2, which turns into positive 1 over 4. It's a fraction, but that's fine. This is our x. We have to plug that in to find our y. So I'm plugging it in into the x's. So y is equal to 2 times 1 over 4 squared minus 1/4 minus 1. It doesn't matter that I changed it to equal to because we're just solving for y for our vertex. The less than or equal to is only going to change where we shade. So I'll change it back to less than or equal to when I get to the shading part. But for now, it doesn't matter. I can say y is equal to. Now I have to follow my order of operations. PEMDAS. Go to the parentheses and exponents first. So when I have a fraction squared, I have to square the top and square the bottom. So this is 2 times 1 squared is just 1. 4 squared would be 16. And then I can multiply these two together. When we multiply fractions, we multiply straight across. So multiply the tops together and the bottoms together. So this would be 2 over 16 minus 1 over 4 minus 1. We can simplify 2 over 16 because 2 goes into both 2 and 16. So I can change it to be 1 over 8. And now in order to add or subtract fractions, we need everything to have a common denominator. So I need 4, 1/4. I need my denominator of 4 to be an 8. So I'm going to have to multiply the top and the bottom here by 2. Make it 2 over 8. And then 1 is just like saying 1 over 1. And I need my denominator to be 8, so I'm going to make it 8 over 8. Now that my denominators are the same, I just combine the numerators and leave the denominator as 8. So this would be 1 minus 2 minus 8. So 1 minus 2 would be negative 1. Negative 1 minus 8 would be negative 9 over 8. Now to help us graph this point, because it's a little bit harder to graph fractions, we could change it into a mixed number. So 8 goes into 9 one time, so it'd be like negative 1 and 1/8. So that's just to help us graph, but you don't have to change it into a mixed number if you can clearly see where that point is at. So I'm going to draw my graph. I'm going to put my tick marks here, putting them far apart just because I do have fractions. Now I need to graph my vertex. So I'm going to go to the right 1/4 and down 1 and 1/8. So it'll be about there. So just a little bit past 1. And then I also need to figure out where my second point is, or my second and third point. So I know that my y-intercept is negative 1. So I cross the y-axis at negative 1. So it's about right there and then there. I can draw my parabola. It'll look like that. Now here, 0, 0 is inside my parabola, so I'm going to pick that point to help me determine where the shading is. I also kind of skipped a step. I gave my parabola a solid line. We knew it was going to be a solid line because it is a less than or equal to. So because I had a less than or equal to sign, my parabola gets a solid line. So now we're going to shade. I got to plug in 0, 0, so I have 0 is less than or equal to 2 times 0 squared minus 0 minus 1. So 2 times 0 squared minus 0 just cancels. So it's 0 is less than or equal to negative 1. 0 is not less than negative 1, so this is not true. So that means I have to shade outside of where that point is. Since the point is inside the parabola and it's not true, I have to shade the outside. So our graph of the inequality should look like this. Now, a couple things to remember. If it is less than or greater than, you need a dotted line. A dotted parabola, I should say. So it should look like that. If it is greater than or equal to or less than or equal to, it would be a solid parabola. And then another helpful hint, I guess, because it may have been a while before since we've done inequalities, so like when we get to the shading part, and we got to see if it's true or not. Remember that the open part of the inequality is always going to point in the greater direction if it's going to be true. So if I had something like 4 is greater than 2, the way you learn in like middle school is that it's an alligator's mouth, so the alligator eats the bigger number, so this would be true. If it was something like 3 is less than negative 1, this is not true because the open part has to be pointing towards the greater numbers. This is not true. So for something that is true, we shade inside. If our point that we picked comes from inside. For something that's not true, we shade outside. Part 2 is similar, but we're going to save that for when I come back on Friday. So don't forget, Wednesday, you need a review for the test that you're going to take on Thursday. So this homework is actually going to be due the Monday we come back from break. I'm going to post it. If you want to start it, you can start it, but we'll go over all of this again on Friday, and the homework will be due after break.